Today we are taking a picture of one of the most brightest and massive star-forming regions of our galaxy. I'm talking about the Swan Nebula, also known as the Omega or Horseshoe Nebula. And this is quite a tricky target to pull off due to its fairly small size and bright core. But I think we've got the perfect equipment to pull this one off. I'm Rajan, and you're watching God's Art. The Swan Nebula sits about 5,000 to 6,000 light years away from Earth, in the constellation Sagittarius. At 15 light years in diameter, this nebula forms part of a larger cloud of interstellar matter that weighs in at 30,000 solar masses, so 30,000 times the mass of our Sun. Within this nebula is one of the youngest star clusters in our galaxy at just 1 million years old, where there are over 1,000 stars forming. One day these will lead to new solar systems, and maybe even life. It's very important to pick targets which suit your particular telescope and equipment. The last thing you want to do is pick a target which doesn't fit the focal length of your telescope, the camera that you're using, or the filter, for example. That's why I was particularly encouraged when I was reviewing the Swan Nebula. Those of you who've seen my previous videos know that my telescope is a Skywatcher 200 PDS. My camera is a ZWO ASI294 MC Pro, and I normally use the Optolong L-Extreme filter, which is a fantastic narrowband filter, only capturing that HA and O3 light. Now this is fantastic for the Swan Nebula. At 1000mm focal length, you've got high magnification, and the nebula fits up most of the frame, along with the L-Extreme filter, which brings out all that rich hydrogen alpha data. So by picking the Swan Nebula, I'm giving myself the best chance to create a great photo. I do also want to get a smaller telescope as well, because the Skywatcher 200 PDS has got quite high magnification, which cuts out a lot of potential targets. So if I get a smaller one, I get a wider field of view. It just means that there's more possibilities in the future. I am open to multiple suggestions, so please let me know in the comment section if you've got a small telescope which you think works really well. I'm looking at the Radian Raptor 6.1, which looks fantastic, but I'm not sure yet. Whilst on the topic of optimal setups, I've also made sure that my camera is perfectly suited to my 200 PDS. As many of you know, the combination of camera and telescope is crucial in impacting the resolution of your final photo. So by optimizing the arc seconds per pixel on your camera chip, you're again giving yourself the best opportunity to get the best photo you can. That's why after extensive research I picked the ASI294 to go with my 200 PDS, because it gives me the best chance to create the highest quality photos I can. I didn't have to calculate any of this myself. I used a website called Bintel, which is where you plug in the numbers and it basically does the calculations for you and tells you how well your setup will perform. So a big thanks to Dylan O'Donnell, which is where I learned about all of this, and I'll put a link into the description for Bintel in case you want to use the calculator yourself. So in case you didn't know, the arc seconds per pixel is basically how much of the night sky is captured per single pixel on your camera chip. Now this is obviously affected by the pixel size and the focal length of your telescope. So it's very important to make sure you check that setup before you go ahead with the purchase. Ideally you want your resolution to be between 0.67 to 2 arc seconds for the best resolution. Oversampling isn't too bad, but it might mean that you've got too many pixels for the current telescope that you're using. Undersampling is a lot worse because it means that stars might be only hitting one or a few pixels, which means that they'll look jagged in the final photo, and that's not a good look. But anyway, we've got the optimum telescope and camera combo to give us the perfect magnification combined with the great L-Extreme filter to bring out the detail in the Swan Nebula. Okay, so we've just finished setting up and we're now going to wait for it to get dark. It won't get dark till about 11:30, which is the frustrating thing about imaging at this time of the year. That's why we'll be imaging it for about 2 or 3 nights so that we can capture enough data to create a final image you can be proud of. I also wanted to make a quick point that I've been revising for my exam recently, so that's why there's been a bit of a delay in the last video to this one. But by the time you watch this, I will have finished my exam, so I'm going to really try and improve the regularity of my uploads, so you should see a lot more coming from me. But yeah, we'll be imaging this from about 11:30 PM to 2:30 AM today, which should give us about 3 hours worth of data on our first night. It is a very still and calm night and the session is finally underway. Similar to the Orion Nebula, the Swan Nebula's got a very bright core, so it's important that we don't blow that out in post-processing. In order to do that, we're going to create a HDR image high dynamic range. And what that basically means is that we're going to combine shorter exposures to capture the bright core of the nebula, and we're going to combine that with the longer exposures which will bring out the nebulosity and the fainter details. This will be done by splitting up the session and doing 30-second exposures to bring out the core detail, and then 3-minute exposures for the fainter detail. I'm also doing 15-second exposures too, just in case a 30 seconds is too long, which will make the core too bright. And the 15 seconds doesn't take long at all to capture, so just want to get that done anyway. All of this is being done at a gain of 120, binning 1 by 1. We're going to image this over 2 or 3 nights, which means I can be very picky with the data that I use, meaning I can only pick the very best sub-exposures. That way we'll create a clearer image and really make this work. So the sub-exposures are coming in now and the stars are looking very sharp, the clarity is there, so I'm very excited to see how this turns out. I can see a lot of nebulosity in that bright core, so I'm hoping we get some really nice detail in the final image. I've actually got the session paused right now while I've got the light shining on it because I don't want that to ruin any of the photos. But we've captured all the 15-second exposures and the 30-second exposures, so now it's just about getting those 3-minute subs, as many as we can, to bring out as much detail as possible. Like I said, we're doing this over 2 or 3 nights, so it's not all on tonight, and we should be able to have a lot of data to choose from. I'm going to be very strict with which sub-exposures I use. I only want the very best quality. The guiding is also going very well, which is crucial. It's generally sticking to about under 1 arc second, so that's allowing us to keep those pinpoint stars. We're tracking the night sky very well. This time of year you get so many flies and mosquitoes, it's so irritating, constantly smacking my face. But yeah, we're going to keep this up for another 1 or 2 more nights, and I'm so excited to see the final result.